we're ready.
Okay, hello and good day, everyone. We're Wiki Group 5 and our project is on ocean acidification on coral reefs. Let me start with some background information. Coral reefs are underwater ecosystem that mainly located at tropics of Cancer and Capricorn, as you can see in the yellow regions on the map. They provide food, shelter, substrate for about 25% of marine organisms. Next slide. Factors like grazing and increase in temperature due to global warming will damage corals' calcium carbonate shells. Normally, they can take up free calcium and carbonate ions to repair them, but this is affected by ocean acidification. So what is ocean acidification? It is when carbon dioxide dissolves into ocean and form carbonic acid. Meanwhile, free carbonate ions will react with hydrogen ions from acid to form bicarbonate ions. So basically, two things happened here. First, the pH of water decreases. Second is that as carbonate ions are consumed, coral reefs have lower ability to produce their shell. This is a major problem because the coral reefs are being consistently damaged by their environment while ocean acidification inhibits their repairing mechanism. And as coral reefs become weaker, they are more prone to environmental stresses such as pollutions and predators. It can lead to coral bleaching, like you can see on the top left, and ultimately destruction of their habitats. If we take no countermeasures, the extinction of coral reefs can happen. There are two main human actions that cause ocean acidification. First, our society have been relying heavily on combustion of biomass and fossil fuels to provide energy. A lot of carbon dioxides are produced in the process. You can see some factories and smokes on the top right picture. Secondly, worldwide deforestation lowers the amount of carbon dioxide that can be absorbed into vegetations. These two combine to produce a net increase in CO2 level and intensify ocean acidification, and once again affect coral reefs' ability to produce calcium carbonate shell. Next slide.
Ocean acidification has a multitude of effects that influence the individual organisms on a coral reef, which ultimately leads to changes in overall ecosystem structure. Calcium carbonate shells are produced by a wide variety of organisms, such as mollusks, urchins, and corals. And as mentioned before, having less available carbonate in the seawater not only makes it harder to produce those structures, but can slowly damage the already established ones. For example, mollusk shells can become weaker, or the larvae of echinoderms can have reduced swimming speed, affecting their establishment. Corals are some of the most vulnerable organisms to ocean acidification, but are also the most integral to the entire reef, as their skeletons are what give most of the reef its overall complex shape. If these structures are slowly lost, the reef loses the complexity it needs to support other organisms like fish and echinoderms that depend on them for food and protection. Next slide. This begins to affect the entire ecosystem as the organisms that depend on coral are displaced, and then so are their predators, decreasing the biodiversity. And instead of coral, low complexity algae can grow. Here I have a little handmade diagram. On the left, we have an abundant biodiverse reef with tropical fish that use the coral as protection. We have a clam, sea urchins, and on the right is what can happen after exposure to ocean acidification. Here, the coral has bleached and perhaps died, and this low turf algae has grown in its place. However, this algae does not give the same kind of protection and food as coral, squeezing out some of those coral-dependent species. And what's left is this less biodiverse ecosystem, made more of generalist species that are able to cope with the physiological stress of lower pH and feed on the new algal growth. Next slide.
Okay, so ocean acidification is decreasing the density of corals and negatively impacting their growth. Ocean acidification is occurring globally, and corals are especially sensitive to the change in the ocean's pH. Some specific examples are in the Galapagos, coral reefs disappear at a pH of 8, and the corals in the Papua New Guinea reefs disappear at a pH of 7.7. In the Great Barrier Reef, there has been an 11% decrease in coral density due to ocean acidification, and in the South China Sea, corals have decreased in density by 7% as well due to ocean acidification. The IPCC report that since the 1980s, there has been a 0.017 to 0.027 decrease in pH per decade in the ocean's surface waters. The continuation of carbon uptake into the oceans will only make the effects of ocean acidification worse. And under RCP 8.5, which is a high carbon emissions representative concentration pathway, the IPCC report it is virtually certain to see a decrease in the open ocean surface pH of 0.3 pH units by the years 2081 to 2100. Now, if you look at my slide, hopefully you'll recognize that coral ecosystems are really special and amazing because they host a wide variety of diversity. And so currently there's a lot of stressors acting upon coral reefs, not just ocean acidification, there's coral bleaching and pollution to name a few others. And so currently, it is projected that global coral cover will decline by 92% by the year 2100. And that is inclusive of multiple stressors, including ocean acidification.
So there are currently no mass-scale effective solutions to ocean acidification. With that being said, some possible solutions include decreasing CO2 emissions. This would mean that countries would need to recognize climate change as a threat and cut down on CO2 productions. This could be in the form of implementing carbon taxes or investing in renewable energy sources. Phytoplankton can help decrease CO2 concentrations by using it for photosynthesis. Phytoplanktons bloom when iron from whale feces is introduced, so increasing whale populations through potential breeding methods could be one way of increasing phytoplankton populations and thus lowering CO2 concentrations. Adding chemicals such as calcium carbonate can help change the pH to a less acidic level. This would be only a local solution as it would be a logistical nightmare, not to mention expensive. A big concern would be that there might be unknown side effects on corals and other marine life, so there must be further research done before being put into place. And the goal of defending corals from ocean acidification is one that is debated. Some argue that it would be too expensive or there would be little to gain from doing so, and we should be focusing on other species instead. Others argue that the benefits of coral reefs, such as providing ingredients for medicine or shelter for other species, far outweigh the cons. Despite all this, there were a few reports put out stating that the benefits far outweigh the costs economically and ecologically, and thus protecting corals is worthwhile. Next slide. So in summary, CO2 dissolves in the ocean and gives rise to ocean acidification, which inhibits a coral's ability to produce and repair its shells. Adverse effects on corals result in an ecosystem shift in which the algae dominate. Global coral cover is projected to decline, and currently there are no mass-scale effective solutions to ocean acidification. Thank you.